I am physics professor Tim Chuck, one of the organizers of Saturday Morning Physics, along with our team that includes Carol Raybuck and Monica Wood and her staff of the Warren M. Smith Demo Lab. Before moving on to our program today, I want to remind you that Saturday Morning Physics is made possible by you, by your generous contributions to Saturday Morning Physics and to from all of the Saturday Morning Physics fans. Thank you so much for helping to make Saturday Morning Physics sustainable so that we can continue to bring you cutting-edge science topics, the intersection of science and policy, and our everyday lives, like today's lecture on artificial intelligence, and family-friendly events. We've put together an exciting program for 2025, including talks on robotics, quantum science, public trust of science, which of course is so important now, and a family-friendly audience participation extravaganza, which you'll find out about coming up in March. Your opportunities to contribute and to continue to contribute to Saturday Morning Physics and the Saturday Morning Physics Endowment include Giving Tuesday, which is December 3rd, but you don't have to wait until then, and you don't have to do it on a Tuesday. You can continue and contribute any day. So for more about supporting Saturday Morning Physics, please go to SaturdayMorningPhysics.org. Saturday Morning Physics is also grateful to have the support of the Dr. Mary Lois Tiffany Endowment, the Hideko Tomozawa Endowment, the Van Loo Family Endowment, and the Pulakeshi Dayalu Astrophysics Fund. But before moving on, I want to note that today's event will conclude with our traditional question and answer session. And for those joining us online, please send your questions to physics@umich.edu. And those here who don't want to come to the microphones, which we'll have set up, can also send their questions to that email address. Now, I'm honored to introduce today's speaker, Professor Nigel Melville, professor at the Ross School of Business. Dr. Melville is an American socio-technical scientist. Wow. Born in Kansas, he grew up living all over the world with a military family. He did his undergraduate work at UCLA and received master's degree in solid-state physics from the University of California at Santa Barbara in 1990, and his PhD is in information science and systems in 2001 from UC, University of California, Irvine. He then worked as a product engineer in the chip industry, as a technical editor in Japan, and he co-founded a CRM, I had to look that up, that's Customer Relations Management, something I don't know much about, a software company. And in 2005, he came to the University of Michigan as a professor of information systems and director of the College of Engineering's design program, which he held until last summer. And he's become an expert on artificial intelligence, which he'll tell us about today. Also, Dr. Melville is a member of the United Nations Environment Program Coalition for Digital Environment Sustainability, CODES, and he consults for large organizations as they seek to digitally transform for leadership in the, I think it's current, fourth information revolution, or industrial revolution, actually, which is the information revolution. Well, anyway, thanks for joining us today and for your presentation, AI in the Business World. Nigel.
So thanks very much. I want to start by giving a big shout out to Tim and his entire team here at Saturday Morning Physics for leading such a wonderful community-oriented institution here at the University of Michigan. So let's give it up for Tim. So I am delighted to be here today and share observations, some research insights, and some of my own thoughts and views about AI. I thought we'd start at the basics, start in the beginning here. Let's see if this works. I need tech support already. Tech support? That's always awkward. Thank you. Excellent, thank you. Okay. All right, so what is AI? This seems like if we're going to talk about AI in business, we should have a sense for what is AI. Well, it's an interesting thing because if you were to ask a high school student, what is AI? They might say, oh, it does my homework for me, and I don't have to write essays anymore. If you ask an artist, what is AI? They might say, an AI cannot do art. An AI actually is a theft of our art to make its art. And for example, if you ask a political activist, they might say, AI is a way to get our message across and maybe get more votes for our side, and maybe even to trick people. So AI can mean a lot of different things. So we really have to focus here on our boundary of AI in business. So let's focus there. This definition, I think, exemplifies a business view. This is by McKinsey. And it says, artificial intelligence is a machine's ability, right, to perform some cognitive functions, things from the neck up, not including feelings and emotions. Those are out. So cognitive functions that we usually associate with the human mind, okay? Kind of a general but useful definition. So now let's look at some milestones, because as it turns out, not only has AI been around for many, many decades, but that same definition has still been true. What's changed is how we go about this technically and how good all these things are, especially in the last few years. So let's look at a few milestones. If we think in the 1970s, we used to call rules-based systems AI, okay? These were hundreds of rules that would help professionals, medical scientists do what they do. It's nice to see a little example. There was a system from Stanford in the 70s called MySyn, a rules-based system that would take in two types of information. The first is symptoms that a patient has. The second is blood test results. And from that information, through rules-based decision-making, MySyn would provide a diagnosis and a course of treatment. Turns out, MySyn was highly effective. In fact, in laboratory experiments, it was as good as human doctors, okay? So this whole idea of we now have AI that's as good as humans, that's been going on for quite a while. It's just broadened in scope. At the same time, we learned an important lesson with MySyn, that just because something works in a lab doesn't mean it works in reality, in the wild, in business. So I just want to quote what they said. Even though it worked very well, highly efficacious, what we failed to see was that adoption of a new tool, right, is not based solely on demonstrated need coupled with high performance, right? In retrospect, that was naive. Acceptability of something new, right, is dependent on other things like legal liability, cost effectiveness, kind of like those business type things, okay? So on the one hand, technically it worked well. On the other, it didn't really change medicine. Now we go into another era from the 1980s. This is called machine learning. So machine learning, the basic idea here is the more information or data we have, the better these machines can make a decision. So we pour more data in, we get a better decision. Business example here, we're all familiar with credit scoring. Credit scoring at scale, at sort of being highly effective, using AI, machine learning, has been going on for decades. So these systems use equations that are called like logistic regression, that look linear and straightforward, like you just give it some parameters, you can get an answer. The part that makes this machine learning It's a numerical solution method that's iterative. Some of you may be familiar with numerical methods to solve equations that are too complicated. So we use a numerical method that goes back and forth between data and answer. Data and answer gets closer and closer. In this case, it's called gradient descent algorithm. That's machine learning. The more data we give it, the lower the error on that strange graph there, and the better off we are. And it keeps going until it gets close. So this is how 80s and 90s we started, mortgages took off and all these sorts of things through better credit scoring. So now we get to deep learning. Deep learning is what many of us are probably familiar with, the idea of artificial neural networks. This is the idea that we can model the human brain very, very loosely, and we can use that model to make what we call nuanced decisions. So now we're beyond diagnosis. We're beyond credit scoring. This starts to go in many, many different directions. So one example is AlphaGo is an example of a deep learning algorithm that beat the world's best chess player in 2016. That was 8 years ago. It was a big thing at the time. And AlphaGo won 4 games out of 5. And the whole world all of a sudden woke up and said, wait a minute, this is a big deal. Because playing Go is the most complicated game that we have. And the combinatorics involved with Go are tremendous at scale, right? Another one, you gotta have a cat, in a slide. Or, it's business. I'm in a business school, so you gotta have a cat in a slide. It's rule 1. So the other one is cat or dog, right? These deep learning or artificial neural network algorithms are great at stuff like that, okay? Is it a cat? Is it a dog? Identification. So these are decisions. But deep learning algorithms actually ushered in something new beyond decisions. And that is what I call creativity automation, okay? Sometimes you hear the term generative AI. I don't know about you, but that's weird and complicated. What does generative mean? I prefer to say, this is an attempt to automate things that all of us, our whole lives, have considered to be creative activities. That does not mean the machines are creative or the outputs are necessarily creative, but it is simulating or emulating that capability. So here's an example. In 2014, we're starting to create human faces out of nothing, out of data that's fed into it. You see the faces each year, 2014 up to 2018? It's getting a lot better, right? So now we've got creativity automation. But wait, there's more. A few years ago, ChatGPT emerged. ChatGPT is an example of yet another milestone in the development of AI called large language models. Okay? Large language models, it turns out, and the particular algorithm for ChatGPT called the transformer model have actually been around since about 2016, 2017. But it took a few years for it to get good enough for a company like OpenAI to say, we have the killer product here, and we release it, and all of a sudden it's the fastest growing app ever in 2022. So large language models are interesting from a business standpoint. So a couple things. Number one, these models subsume the capabilities of earlier models. Now, occasionally I talk to business leaders, and just because LLMs, the latest, greatest AI, can do what the old AI did, it doesn't mean they're switching over immediately. Why? Well, there's switching costs. They've got the stuff. And they tell me, if it ain't broke, don't fix it, essentially. But over time, those older models will inevitably sort of fade out, in my opinion. So now LLMs, what's so fancy about this? They do what other models did, but they actually do quite a bit more. They do 2 things that until recently, most people didn't really give them enough credit for. I've been studying these models since about 2016, 2017. A paper I wrote, which is cited at the bottom, was finally published in 2023. Talk about a long time for it to come out, right? And I realized early on that it's not just cognitive functions of decision-making, generation, right, creativity automation. It's two other things. One is these large language models, by their very nature, have the ability to work together. Now, in a business school, we spend a lot of time on teamwork and teams. We have a lot of group projects, and it's super important to understand why teamwork wins. Get different people together with different skills. They're better as a team than just individuals. We know this. Well, it turns out the same is true for these machines. These machines have been teaming for years, and now they're starting to team even more, and things are getting very interesting. I'll give you an example of that in a moment. The other one is relationship with humans. How many of us have a name for our automobile? It's like, oh, yeah, okay. This is what we do. We're human. Let's embrace it. We personify objects. So if we call our automobile a name, it makes sense that if we have Alexa or Siri, we start calling that a name, or Claude, whatever we have, these little bots. And now that they become more human-like, that will happen more and more. That will be a shift in how we do things, okay? So each of these individually is very interesting. And the top two, kind of new, right? When you put them together, there's a combinatorial innovation that goes on that is extremely interesting. That companies today are at the beginning of figuring out what to do with this. So it's one thing for me to talk about that, but I thought I would give you an example. Suppose I was giving this lecture and I wanted to have an AI collaborator describe this slide for me, because I wanted to give my voice a rest. I thought it'd be fun. So I would tell this AI collaborator, hey, AI collaborator, I'm doing a Saturday morning physics lecture, and I want you to describe what you see on this slide. And I'm not going to tell this AI anything about what this stuff means, because I assume the AI is smart after all, or why would I be wasting my time? And I want you to make it kind of fun and contextual, so the audience understands that this was made for here, okay? So I did that. I said, look at this PowerPoint slide, create a fun podcast about Melville's Saturday morning physics. So let's listen. I lost my cursor. Oh, there it is. Can I get a little assistance? I have lost my cursor. Oh, there it is, Okay. I see it.
Okay, so picture this. It's a crisp Saturday morning. We're in Professor Melville's Saturday morning physics lecture, and there's this electricity in the air.
I know exactly what you mean.
Like something amazing is about to happen. He's just finished drawing this really interesting diagram on the board, and it's all about large language models, or LLMs.
Yeah, LLMs. It's fascinating stuff.
And this diagram, it's like a roadmap or something, right?
Kind of. It shows us exactly where LLMs fit into the bigger world of AI.
AI, that's artificial intelligence, right?
Right. And the diagram, it's a series of these like nested boxes.
Ooh, I like visuals. So AI is the big outermost box.
Exactly. AI is the broadest category. Think of it as like the umbrella term for anything that allows a computer to mimic human intelligence.
Okay, got it. AI. What's the next box in?
So inside the AI box, we have machine learning. It's like a subset of AI focusing on algorithms, those sets of rules that computers use. And these algorithms can learn from data and make predictions.
Interesting. So AI is the overall concept. And machine learning is how we start to actually teach the machines, give them the tools to be intelligent.
Exactly. It's about enabling computers to learn from experience without being explicitly programmed for every single scenario.
Okay, and this diagram, it keeps going deeper, right?
It does. Inside the machine learning box is deep learning.
Deep learning.
Mm-hmm. And deep learning uses these artificial neural networks, kind of like the way our brains work, to really dive deep into massive amounts of data.
So these networks are doing the learning, right? Figuring out patterns, making connections.
Exactly.
Okay, I'm going to stop it there. Now, sometimes when I'm teaching at Ross at this point, I'll say, show of hands, who would prefer to learn from a machine like this versus me? And when I used to do this like 5 or 10 years ago, my students thought I was kind of crazy because what you just saw was not available, so I had to describe it. And they really thought, boy, this guy, I don't know, he's out there. But last year, in the fall, or in the winter semester, when I said, what would you prefer? Many of my wonderful students looked down in here, because the truth is, they're looking at that going, that's kind of fun. I'm kind of open to that. This is where we are, okay? That's one example. Okay, so now we have relationship with humans. And again, some of you may say, well, yeah, you call your bot a name and, no big deal. And I don't mean anything like weird here by relationship. I just mean collaborating, working together, right? Like there's names in industry, they call it things like co-pilot, or I don't know whoever got that term, but I don't think that's so good. I would just call it a machine assistant or a team member. That's a machine. So what does that look like? Okay. So I have another demo. The volume is low, but I'm just going to describe what it's doing for you. Okay. Just to give you a sense for what this looks like as we start working with our team collaborators.
To San Francisco next week.
Okay. First, I'm going to describe the setup. Okay, hold on. Okay. So the setup is you have a friend that's coming to visit you, right? And what do we do when people, family visit? We want to create activities. And so we sort of Google around and find something that's interesting. If it's a summer in Ann Arbor, maybe where would I go kayaking? Because there's a river here, I understand that. And where would I park for this? And then we find stuff, and this is one of these should take 5 minutes, and then an hour later, we're like, where'd the time go? Can't believe it. So we find it, and then we say, oh, there it is, and we put it in our calendar. Okay, some of us enjoy that, but I think a lot of us think that's kind of like drudgery. We want the output of it, but we don't want to do a lot of the work. So we now have a machine called computer use, where you give it one prompt. Here's the prompt, friend coming to San Francisco, where's the best place to see a sunrise? Put it in my calendar. And I'm just going to play it. You don't have to hear what's going on. But everything you see is being done by the AI after the prompt. Everything you see. So let's play it.
Find a good place to see the sunrise to help me figure out timing logistics.
Okay, so you'll see it change. So the machine knows to open up a browser, to Google something that makes sense based on the prompt, to identify one of the things that makes sense here, 10 best places to see. Open the article. Find the location where you are versus where that is, right? Because we have to know like how early to wake up to leave. Okay. There's our route. There's how long it takes.
Cool. So now it looks like Claude is searching for the sunrise time tomorrow.
Google. 7:20. Yeah. What do we do next? Open the calendar, paste stuff in, share the calendar with the friend who's coming to visit. Okay. Okay, so I'll stop it there. So you can see how, wow, we have now machines that can sort of, make a podcast, like do stuff for us like this. This is a whole new world. And if you're a young person in today's world, the way that you go through college and your early work years and your later work years are going to be completely turned upside down by these types of things and what's coming.
I'm going to San Francisco next week, and I want to take him to do some touristy stuff.
Okay, so this was the examples around inter-machine teaming in relationship with humans. You could see that second example. If you start doing that on a regular basis, this really does become like your assistant. You start talking to it, and it starts learning your own particular likes and dislikes, and off we go with the relationship with humans. That's today. Now, I don't know about any of you, but I've never given, I have student assistants. I never have them in my office and say, I need you to, do a summary of this article and then put it over here, and then let them sit in my chair, take over my machine while I have to watch it, which is how somebody designed this. Makes no sense. So that's today, but very soon, speculative here, we're going to have a future where these machines live in the cloud. They have access to the internet and everything they need. You send them a work request, like the one you just saw. They will find something that they need from you. And just like today, we have these little pop-ups. Hey, can I access your calendar? Same thing. Can I access your calendar? And then when they're done, meanwhile you're working, they're working, they'll send you a text message, a Slack message, an email. Hey, I'm done. What else do you need doing? Okay? That's our very near future. Very near future. Okay, so machines' ability to perform some cognitive functions we usually associate with human minds. Second question, how fast is this really happening? I allude to these things happening so quickly. What is the data telling us about this? So each one of these curves represents one of these capabilities or cognitive functions. Like the first one, the far one in 1998, the sort of maze one, is handwriting recognition. And you'll notice that at the bottom, it started in 98, then it goes up to the right, and it passes that human performance line as kind of a benchmark for quality way over there in 2012, okay? So that's more than 10 years to get to human quality. So the slope of the line is sort of associated with speed. The more vertical, the faster. What do we see here to the far right? All the lines are getting like delta functions for you physics people, or just vertical. It is going much, much faster. Code is on the right, grade school math. We are now up to PhD level physics and chemistry, the latest models. That line would be another line that's not even there yet. That would be a vertical line, less than a year, okay? This is how fast this is going. Part of this rapid pace of change is because the conversation memory length, I call it, the technical people have these terms like context window. What in the heck does context window? Nobody knows this. But conversation memory length, meaning how long do we usually have conversations where we have to maintain in short-term memory everything that was said, right? Couple hours, 3-4 hours. Well, we're at a point now where we can talk to these machines. They can keep up to 11 plus hours of a conversation in their short-term memory with very high fidelity. That means this is like a kind of a conversation that we've never had. Because I don't know about you, but I do not have perfect fidelity when I talk to people. I aspire to it, but I don't. They have perfect fidelity. So we've only just begun. Where we are now with these models and this AI revolution is where we were in the late 1800s, Mercedes-Benz, first automobile. In the middle, the first internet was a top-down directory, not a search window. At the bottom, AOL email. That is where ChatGPT is today. We are at the front end of a massive amount of innovation that is coming our way. Okay? And of course, the LLM vendors like OpenAI and Microsoft, they agree. This is one of my favorite quotes. The AI systems we have today are laughably bad. Today was May 6th of this year, so like 6 months ago. Laughably bad, okay? In the future, they will be capable of much more, or they will be more capable of much more complex work, okay? So laughably bad, right? And this is turning out to be true already, because since May, we've got a model that reasons, that will tell us the reason for why it's doing things. Some of the demos I just showed you have come up within the last 6 months. Okay, so that's speed. So let's get to business. Like, what is business doing with all this possibility? If you step back, and again, this is from some of my research that's under review now at the bottom, and also from observations with corporations and leaders. There's really two approaches here. One is the low-hanging fruit, just more, better, faster, right? Let's do the same thing we used to do and do it like 50% faster, okay? More, better, faster. These opportunities are available immediately without a lot of change in organizations. That means it's likely to happen faster. The bottom is strategic. This takes longer, but it has much more of an upside. So this is transforming core operations, and some of you may have heard this term AI-first organization, meaning there are some companies today, global Fortune 500 companies, that are looking at these opportunities and saying, we need to be AI first in everything. How are we going to do that? Now, that's going to take time, okay? But that's what they're looking at. University of Michigan is up there, better quality. We now have, AI tutor that may provide a better learning 24/7 for students as a complement to what we do, to what teaching assistants do. Faster speed, we're using it here for contracts and compliance and other things here at the university, okay? And then down in transformation, I'll show you some examples in a moment of corporate blue chips like Walmart, Goldman Sachs, and what they're doing. They are basically changing their entire companies to leverage this opportunity. Okay, so tactical, I mentioned University of Michigan. Eliminating drudgery, that's a big one. So drudgery is like all those things in companies that we don't like to do, like spreadsheets and things that don't add a lot of value, repetitive, low value, etc. The middle one is making IT systems easier to use. I'll give you an example of this. Many of us in this room probably have Payflex. Oh, I'm sorry, they changed to Inspira. Oh, I'm sorry, they changed. And it changes all the time. And every time we go log in there, every month or so, where's this and where's that? Who can figure this out? Okay, so these systems will be like a little search window there on the side, little chat window that we can just type in and say, how do I figure out how to upload this document? Or how do I figure that out? And they'll help us. So making IT systems easier to use. Air France has been doing that. Ford Motor Company and other companies are using the software development co-pilots, which essentially help software developers code by both giving them code and checking their code and making it all go much faster. So that's a more, better, faster. Ford Motor Company reportedly has thousands of its coders using that method today. And to give you a bigger landscape picture, if you look at all of these blue chip companies that we all know, they're all using applications of large language models. Just to give you a sense for one of the creativity automation examples, IBM and Deloitte Consulting are using this, what I call creativity automation, or Gen AI, for their logos, their visuals across all of their channels. So when you see, like you Google something or you get an email or something's in there, some of those are now created by AI. Why? It's way faster and way cheaper, and it just makes sense, okay? I'll get to risks in a moment. So the other thing is, once we go from more, better, faster to strategic long-term, this is something that I've observed with a few companies that I've worked with. It requires a mindset shift. And what I mean by that is, we humans are not so great at imagining the very, very small and the very, very large. We're just not wound up to do that. I studied quantum physics and solid-state physics, and let me tell you, it took me years to get an intuition for the bizarre behavior of matter at that very small level and the very large. We're so bad at it, we invent new metrics. So distances are no longer like miles or something like that, right? They're like light minutes or something, because that is something we could understand maybe a little better, like amount of time it takes, light to travel a minute, something like that. So, very difficult, but some companies are doing it. So let's look at Walmart. Walmart is using AI in a variety of ways. It only has discussed some of them. This one comes from an investor call that was obviously public recently. So if you go to the Walmart catalog online, you see a page like this for televisions. Anybody want to make a guess how many such pages there are in its online catalog? Walmart? Lots? I don't know, million? 10 million? 100 million? Okay. Anyone? I don't see any arms up. Okay. 50 to 60 million products available online. So right out of the gate, that's hard for us to get our minds around that. At the same time, each page has a bunch of pieces of data, pricing and quality and features, which are changing all the time. So 850 million pieces of data in their catalog, right? 850 million, almost a billion. And these are constantly changing, errors emerge, it's a massive problem. So this is where this new thinking comes in. Many problems exist like this in society and business that we have never really been able to solve well because it was not economically feasible. It was just too hard. So what have people done? They've done the best they can, right? So they have people doing it, they try to use some automation, but inevitably you go to the page, we've all experienced this, and you click and it's not exactly what they said it was, and you're like, why is that? And well, it's hard to keep up. So Walmart said, we can solve this. They use multiple large language models to both create some of this data, but also to error check it. So this is like quality, to make sure that whatever is on that page is what the manufacturer or supplier provided. And then they said, without the use of these models, this would require nearly 100 times the headcount. Now, I'm guessing what they're not saying is we couldn't afford 100 times the headcount for this particular problem. But with large language models, we can do that. So this represents a 100x productivity improvement. Those are the kind of numbers that corporate leadership at the very top are very tuned into. Okay, so in the interest of time, I won't go in too much to the Goldman Sachs example, other than to say Goldman Sachs has several lines of business. One of them is investment banking, which is part of the work is pricing mergers and acquisitions and pricing when a company goes public, what should the share price be? Requires a lot of analysis to figure out the right number. AI is being used to help synthesize, identify, and present information to help the people that do that. Asset managers, this is portfolio management, optimizing different investments according to certain criteria, same thing. And then, of course, software development. So Goldman Sachs basically developed and consolidated all of their machine workers, you could call them that, and said, okay, we've got them all here. We're going to train them to do certain things, and then we're going to deploy them. That is what I mean by kind of an AI-first attitude. This is not experimental. This is not piecemeal. It is systematic, and it is top-down. And finally, for those of you that like data, there's lots of surveys on this, but this one's pretty good. So it's 2,000 plus corporate leaders, chief information officers. How are you using AI, if at all? more than 70% of the companies surveyed said they are either using it in production. This means like it's helping customers, it's like doing back-end stuff like Walmart, or they're experimenting with it, okay? That's a big chunk. And most of the others are planning on it. And then there's this 4% holdout. I would love to know who that 4% is. We're not going near it. We're not going to do it, and there's probably good reasons for that, okay? Okay. It's a pretty good picture so far, right? So now we're going to turn and face the other side of the coin, which is risk, okay? Because always with opportunity comes risk. And with AI, we have very particular, unique risks that are emerging. About a year ago, I started teaching my students about the risk aspects, and I wanted to find a nice risk diagram, and I couldn't find one. Okay, and I thought, why hasn't someone created this for me? So I had to create it myself. This is completely illustrative. This is not based on data, but it is a schematic or illustrative representation of the types of risks and giving a sense for near term versus farther term. So if we look at the lower left, which is near term, and then kind of see how negative it is, this is imperfect capabilities. These are bias, getting the answer wrong, giving bad advice to our customers, saying something to a customer, if it's a verbal application, that could be considered problematic, okay? Imperfect capabilities. Now, if we go one up, workforce displacement. So there is a pretty major sense that we are going to have some shifts in employment. And there's lots of sides to this, and I think this is such an important issue, maybe it'll come up in our discussion, Q&A afterwards. But to suffice to say, nobody knows the extent to which jobs taken away by AI will be substituted for by new jobs. Nobody knows. Okay? So that's an open question. Nonetheless, there is a lot of consternation and concern. Recent strikes by dock workers, by Hollywood creatives, this is what they're striking about. Okay? They are anticipating those sorts of shifts. They're seeing them now. So it becomes like an anti-automation. And then the other one I would point out is criminal or unethical applications. So this is like making cyber risk much worse, because now it's going to be, how good are your machines at attacking my defensive AI machines? That's the future, and it's already happening. Okay? Now, there's some things up there to the far right. I do want to just mention that star up to the far right. I want to clarify one thing, the Terminator scenario, right? That we're going to have some kind of like machine that all of a sudden is going to emerge, that is going to have like sort of a self-awareness kind of thing, right? Some kind of singularity event, and we should be very nervous about this, right? I want to say something because this is very important. There is no physics, there is no evidence, there is no theory connecting where we are today to that eventuality. So I'm not saying that will never happen, but we have no knowledge in all of our disciplines saying that could happen, okay? So we'll just leave that at that. Okay, so just some examples, AI can go wrong of imperfect capabilities. It can look at a person and say, oh, I think that was a shoplifter in our database, and then it's wrong, and it's very costly. It's a public relations disaster. Another one is for workforce displacement. The machines are getting better. People are getting even more nervous as time goes on. This latest model, I mentioned it earlier, exceeds human PhD level accuracy on benchmarks for biology, physics, chemistry, etc. That's a pretty big deal. Does that mean it's better than a PhD in physics from the University of Michigan? No, not necessarily. I'd say no. Tim says no. I want that noted for the record. But it says something about the quality of what these machines can do. And then I do want to say something about energy. There is a high energy use per query. There is a high energy use for training. And there is a modest energy use for queries, meaning like when we prompt these machines. These AI data centers, to take one example, have an energy draw of 25 to 35x versus like a regular data center. So when you hear about, oh, such and so company is building a data center for, for this AI chips, those are really heavily energy using, which creates two problems. We don't have enough energy right now. That's a problem. We don't have enough power generation. And second, if it's carbon-based, right, that's a problem with emissions. So two problems. Now, we have the other side of the ledger. Market forces are helping us somewhat. So market forces, the companies making these machines fully realize that this is too energy intensive. So here's what they're doing. They're taking these huge energy hungry models and figuring out ways to lop them down by like 50% or more. In fact, some of the models now, like the one I have, can just fit and run on your own phone. That's a much smaller model that's as good as the big one, maybe 80% as good. So it could be fit for purpose. So that's the first one. Second one, nuclear fusion is being developed. So instead of splitting atoms, you join them together. There's upsides around things like no nuclear waste, but there are also downsides. But that's going to take like 10 or 15 years. So we're far away from that. And then finally, the chip makers like NVIDIA are highly incentivized to make the chips that run all these LLM algorithms smaller and more energy efficient. And they're doing it. So we've got some market forces that are working in our favor there, but we still have the issues on the left. Okay, so let's get to, going to be wrapping up real soon here, what we don't know. When I think of what we don't know in this space in terms of how we use it, risks, things like that, this picture comes to mind. How many of you have ever driven in this sorts of weather? Okay, yeah, most of us have. And it's kind of scary because you know that car's in front of you, but that's about all you know. And you also know that if you're traveling at about this distance, as the picture shows, that car makes one mistake or swerves and curtains, right? This is about where we are with this AI stuff, both on the value side and the risk side. There are a lot of unknown knowns and a lot of unknown unknowns, meaning things we don't even know about could happen, okay? And we need to be very careful. Companies need to be careful because they have fiduciary responsibilities to their investors. Society has to be careful because what are we unleashing? Let's look at some examples of what we do know. So we do know, we have some lab experiments that are being done that says, oh, it can help us with writing and quality and making us better writers and speed, okay? So we're starting to learn that. All these studies have come out in the last year or two because these large language models have only been around that long. We also know that customer service agents, which is a big application domain for large language models, right? Helping all those customer service agents like Delta Airlines serve us, help us or those agents to know what we need, anticipate. It's helping on the left, helping them to do their work faster, okay, which is good for those companies. But one interesting result on the right is it is affecting the junior levels in a much more positive way. So the newer customer agents are getting a much bigger lift to their speed versus the ones that have been around. So again, it's only one study, and we'd have to get a much more broader set of studies to confirm this, but that's an interesting finding. We also know, this is a recent JAMA study that came out just a month ago. It's a pretty good study, and on the left here, the study says, well, if we put sort of an AI assistant with doctors for diagnosis, it's not really better. No statistical significance there. That's the headline in the research article. Okay, so it's like, okay, well, maybe we need a better assistant or we need to figure out how to help them work together. The headline in the New York Times is that the AI chatbot all by itself, without any human assistance, did better than the doctors. You see the difference in what's being told to us and how it's framed? If you go back to the original article, that result is not in a results table. I know because I read it, because I thought, that seems like an important result. And I had to go find it at the bottom of the results section where they said, oh, we did test just the machines by themselves, and yeah, significantly better than the doctors, okay? So we have to be discerning in how we, all of us, take in and understand what we're being told about these machines. Okay, so here at the University of Michigan, we have lots and lots of great examples of how we are contributing to knowledge generation. We have rolled out some infrastructure that allows our students and the rest of our community to use some of these models and learn about them on the upper left. We've got some incredible gifts, one of which is healthcare AI that just was announced recently. This is over in the medical school. We have Midas, right, a whole institute, and then we have individual research groups like Radha Mihalcha in computer science and with her lab in language and IT. So we have some things here. That's good news. But then we have to think about the future. What future do we want to create here, right? Like, this can go in a lot of directions. So I'll tell you one thing. I don't want this future, okay? I don't want social media part 2. I don't want a world where companies are rolling out technology like AI, learning that it's not helpful. In fact, it is harmful to certain groups, and suppressing that and moving forward anyway. That's what happened with social media. It is beyond irresponsible. It's criminal to do that. Okay, so I don't want that world. I don't want this world either, where people are falsely accused of things, put in jail, and, then they're just let out and said, sorry, we made a mistake. Unacceptable. That's not the world I want. If we're not careful, we're already starting to enter that world. Okay, so Houston, we do have a problem here. Okay? We do have a problem. So, sort of ways forward. The University of Michigan could be a leader in interdisciplinary research that's human-oriented, that addresses what I consider to be, what I call, these sort of AI grand societal challenges, okay? So one of them, upper left, transparency. Lots of people say, we need transparency with AI. All that means is when you're using an AI that sounds like a person and you're not sure, there should be a way of letting you know, I'm an AI, right? Now, this has been typically a technical problem. Oh, we'll hide some code in there or something, and that's great. We need technical solutions, but I see this more as a socio-technical problem. How about just every AI that you talk to must say, hi, this is Claude, I'm an AI, but I'm still pretty good. What can I help you with today? Is that difficult? And here's another thing. One of the biggest pushbacks to this is, oh, it'll make mistakes. People will go around it. Yes. Just like any regulation or law, there's always people who will find a way out. But we cannot let the perfect be the enemy of the good here. We cannot let that argument stop us from making these efforts. So lots of other things. Bias, that is a socio-political problem. AI teachers. Here at the University of Michigan, we say, oh, we've got this study that says, using this AI tutor kind of helps here, and that's great. But this is really a socio-technical problem. What do the students think of this? Why are they using it? When do they use it? How do they use it? And do they think it helps them? And does it help other things beyond just learning? Does it help their sense of efficacy, self-efficacy, right? Does it help their wellness? All kinds of questions there that we should be asking, and we can ask. And I'll give you a sense for just the beginnings of how this is happening. And there are probably other groups on campus, but I'm involved with something called the AI Ethics and Equity Research Group that is sponsored by Rackham. And I made this to look like the top of a conference table. So Rackham is in the middle, they convene us, And we sit around as a group from various schools and colleges, a philosopher, a computer scientist, somebody from business, public policy, and we discuss and engage deeply with these kinds of issues. So we are the beginnings of a foundation to how we can start grappling with this. Okay, so new types of thinking are needed, obviously. And then sort of a almost final slide. This work has to be done. And we can look at large institutions who have the resources and time and say, well, why don't you do it? And the first one there is like corporate America. There are some very good people in corporate America who care deeply about these issues. But at the end of the day, the incentives in a corporation do not align well with these sorts of questions around transparency and bias, et cetera. It's just the way it is, okay? So that's out. The middle one, government. Government also has some very, very smart people who care deeply about these issues. But there are also incentive alignment issues there. There's also pendulum swinging in political thought about the role of government, okay? Regardless of where you are on the political spectrum, we know things go like this. And there's also an informational gap. There's not always the level of technical expertise that's needed in the government. It's getting better, but we're not there. We're the only ones left. We're it. We, as an institution here and others, we're pretty much the only one standing in the way of some of those futures that we do not want. We have got to step up. Okay. I have an acknowledgement, and then I'm done. So I decided to call out two individuals that played a significant role in why I'm standing before you today. There are many, but I'm just calling out two. So first is Professor Herbert Kromer, who taught me solid-state physics. He's a Nobel Prize winner. But what I really learned from Professor Kromer, what I think the best professors do, they teach us how to think. And Professor Kromer taught me how to think. So thank you, Professor Kromer. And then the individual on the left, Professor Henry Samueli. He taught me digital circuit theory in the late 80s. And a few years later, he founded a small company called Broadcom. Broadcom grew and grew, went public, and Broadcom today is a $767 million as of Friday, $767 billion market cap company as of Friday. Henry Samueli, some of you may recognize the name, with his generosity, it is now called the Henry Samueli School of Engineering at UCLA. So what did Henry Samueli teach me besides digital circuit theory? He taught me how to envision futures and make them happen. Because when he was lecturing us, he wore that suit and a tie. And he was the only engineering professor I saw that said, I thought, you're different. Most of my professors are like in t-shirts and jeans. That's just how it rolls. And then he comes in dressed in a nice suit. And he would spend 10 minutes each lecture talking about what we were learning and how it was going to be the basis for these weird things that nobody understood called cable boxes, right? And we in his class were like, cable boxes? He envisioned an entire industry around cable television and then skated in that direction and made it happen. So thanks, Professor Kromer. Thanks, Professor Samueli. Thanks to all of you. And I look forward to your questions. Thank you.
Wonderful and masterful. Thank you very much, Nigel. Okay, so we will move on to the questions. Several have come in from the online community, and we'll get to those in just a moment. So for those of you here, we'll have the microphones ready and get going as soon as they're up on the stairways. So let me just start by asking the following question. Back to the elephant in the room. at the very beginning. So all these people are not blindfolded or something, touching different parts of the elephant, and they have a different idea of what it is. I wonder who would say that AI is a risk.
Oh, lots of people.
Yeah.
So there are some people who think that AI is just the worst thing. They don't want to use it. It's risky, it's dangerous, and we're going to throw away our futures by letting AI do all this stuff for them. So it's not a big group of people, but it's an important group of people. It's important to hear what they have to say. And the other group, which is not as extreme, is many in corporate America have experienced these risks. And so they understand that things can go wrong, and they need to step back and plan to mitigate those risks. Yeah.
Okay.
So, yeah, different groups.
And not the people who've seen the Terminator, or?
Yeah, there are some Terminator people. They might be in that first group. I don't know.
Yeah.
Because
Okay.
I love the Terminator movie myself.
I'd like to urge the people here in the room not to be shy. Think about your questions. Yep, here comes one.
Thanks for the
Microphone on.
Thanks again for the presentation. It's interesting. I just got done reading Kahneman's book and Tversky, who are two famous psychologists right here from the University of Michigan, who won a Nobel Prize. And they do talk about the benefit, how you position technology in terms of risk and benefits. And that's significant. I saw that with your slides. I'm going to ask you a quick question in terms of what I see. I'm currently working with high school students, and I got a hypothetical question. A lot of them are applying for college, of course, and so I have a juxtaposition. One's called student, and one's called student athlete. So what would AI do in terms of looking at the equity between a student who's going to take on thousands of dollars of debt versus a student athlete who's going to get paid millions of dollars? What would AI come up with?
Okay, so I want to make sure I understand the question. So the AI related, so I understand the context, but the AI component would be if you were to ask an AI a question around equity here. Okay, fair enough. There is a new AI model called O1. And what is very useful and innovative about O1 is not necessarily the answer, but the reasoning that it takes to get there. And I don't know what it would say in this scenario, but I think it would do a pretty decent job, based on my own experience with it, at laying out sort of the different potential, let's say, policy mechanisms or approaches, and going through in an evidence-based way with citations the kind of pros and cons of each one, and then making some recommendation at the bottom. But I find when it does that, that the actual logic and sources are better. So that's a roundabout way of saying I don't know exactly what the AI would say, but that's the style of response that could help all of us grapple with what is clearly a difficult question.
And looking at currently what's happening today, I know of two engine plants in Michigan. Actually, one in Windsor, one in Michigan. There are lights out.
Yes.
That
Yes.
basically need nobody except the metallurgical engineers. That's it. Thank you.
Thank you for your question. Yeah.
Yes, I found I was confused a bit by the slide that gave the article from JAMA comparing
Yes.
doctors' things. The headline seemed to me, and I couldn't figure it out, that it was saying AI was better than AI alone. And
So which one, the JAMA article or the New York Times?
I think it was the JAMA article.
Okay, so the JAMA article, the headline, I think, or the title of the article was essentially, an assessment of efficacy, blah, blah. But really the key finding is that doctors alone versus doctors plus AI, no significant difference in diagnostic quality. That's really the headline for the article. Okay. For the JAMA article. For the New York Times, they decided to focus on something that they found a little more interesting, which was studied in the paper, but not as a major component of the paper. So does that clarify it?
Yeah, I think so. Actually, the confusion I had was the slide's subject, if you will.
I see.
Title on the side.
Yeah. Okay. Thanks.
So coming in online,
Yep.
there seems to be a little hostility
Okay.
towards AI.
Yeah.
One of them starts garbage in, garbage out. And the question is, how can AI determine which data is valid and therefore usable and generate answers or products? In other words, what happens when AI starts being as gullible as we are? Or is it?
So this question is also related to bias. I get questions a lot about, we're biased, and our data went to train it, so we trained the machine to be biased. Now, on the surface, that logic is correct in both cases here. However, there are phases of training that do not involve the data themselves. And I'll give you, that come after the main sort of pre-learning. One of which is called reinforcement learning with human feedback. That means you literally have the machine ask or answer a set of questions, and you have real people saying, good, not good, good, not good. So that kind of thing is how we end up, partially, with a ChatGPT product that very rarely provides what we might call controversial or troubling responses. Without that and some other post-training phases, we would have much more of that. So I would really call it sum total of human output in and curated versions of that out. That's my version of what's happening. So it's a good question. It's a fair question. Yeah. Another question?
I have two examples of problems with AI. One is in your San Francisco
Yes.
Demonstration. The bot did not check the time of the sunrise, sunset, before checking how long it took
Excellent.
to get there. The second I have is telephone answering bots, we've already experienced.
Yeah.
I've developed an IQ test for the bots.
What is it?
Secretary or telephone operator can usually get you to where you want to go in 30 seconds. A bot that takes 5 minutes or 10 times longer would have an IQ of 100 divided by 10, or be 10.
Oh, interesting. Yeah, I like that. So good catch on the first part. I think it's a great example of imperfect capabilities. It gets a lot of it, and then it forgets something. And we're not there yet, but we're slowly getting better. And on your bot IQ test, I've never heard of anything like that, so that's interesting. Yeah.
It's useful when you complain to people, when you finally get to somebody, you tell them how bad their telephone system is.
Yes, absolutely. Thank you for that. Yeah, over here, I think. Yeah.
I'm interested in the environmental impact.
Yes.
And are there, because the AI clearly has the opportunity to be very beneficial for some of the businesses that may engage it. And are there any regulations around power use? Because I feel like this is growing exponentially without kind of necessarily the oversight and the impact on environmental aspects.
You're basically right. You're spot on. Most of the metrics for assessing power use are the same ones that we've always used. One is called PUE, power use effectiveness. So how much of the power to a data center is going to the chips versus other things like cooling and so forth. And there are some researchers that are starting to look at that problem and are starting to look at it, say, life cycle analysis. So To what extent are they using renewable energy to power the data centers, et cetera? So that's good, but we're way behind. We need much more of that. And I think people in the environmental disciplines are a good start because they have been studying these issues. And I think some of those multidisciplinary opportunities that I spoke to, get a computer scientist together, specializing in data, hardware, data centers, and get an environmental scientist together and start unpacking what are the issues. And I see this, we're in a period where we need this so urgently that we need to start thinking it's not just research, it's advocacy. It's being a voice, using this great University of Michigan platform to say, like, be a megaphone so that people will listen to us. And I really think it's a responsibility now. Yeah.
I mean, it feels very challenging because, you know, the people with a lot of money already have the bigger voice, you know, with the potential to make even more money.
Yes.
So you see the universities, that kind of angle as being needing to be the advocate.
I think that's one. Okay. I think there are others. So there is something called NIST, which is putting together guidelines for sort of risk in general. I think something like NIST, a third party that is widely respected in other areas, people know about NIST. If NIST would say, we are developing data center, the large ones are called hyperscale, okay? Hyperscale data center requirements, regulations, guidelines is probably a better word. I think that could also, sort of start moving the needle, but we're behind.
Who funds and supports NIST?
That's a good question. My understanding of it is NIST is a not-profit that's funded by sort of two main things. One of them is corporations. And then there's also other funding sources. But I'm not sure about that. You would have to check. But that's just an example of there may be third parties that can also possibly even collaborate with universities to start focusing on that specific.
I can see where with, you know, resources, people could create like kind of window dressing opportunities. Like we're looking at it, but we're not, you know, committed to
Absolutely.
changing it.
Yeah, and when I say advocacy, I mean, part of it is, like advocacy where you find a way to force companies to provide data, right? And this has happened in other environmental areas. Then you cleverly make that data transparent to one and all so that people can see for themselves and maybe even compare across industry. Like, wow, look at what Amazon is doing versus what you're doing, company X. So that's also a way of kind of, crowdsourcing and getting the public to be more aware of this. Yeah, definitely. That's a great question. Yeah. Mm-hmm.
We do have a lot of online questions.
Yeah,
it's amazing.
sure.
There are over 100 people viewed
Okay,
online, and
great.
several questions are coming in.
Sure.
This one's a pair of questions I have bundled. One is, maybe came in early, why is facial recognition so good? Why was that such an early success of AI? And the second part of that question is why and how can it be racially biased, or is that in fact an anecdote? Just a bad example.
Great. So I can say a little bit about the facial recognition. So I'm the worst drawer in the world, but if you look at kind of like a face, it's really pretty straightforward how this works, right? The technique is this name called convolutional neural networks, but essentially the machine looks at it first and just says, hey, there are sort of line sections here, there are circle sections. Then it says, oh, circle sections can be combined into oval section. And then the next layer up, the ovals start looking like things called eyes. And if you're a cat, same thing. You have ears that look like that. So this is something that's been going on for more than 10 years. And when it comes to vision, we have ways that we've already created that then the LLMs build off of to sort of break down images into lines, arcs, combine them, and then combine that into a bigger face. So that's a sort of a just intuitive glimpse into how that works. This is the weirdest diagram ever without the other one here. So now you can see how bad I am at that. Okay, the bias. The bias is not anecdotal. The bias is real, and there's good, strong evidence, for example, that the darker your skin is, the more difficult these machines have in identifying you, have in identifying your gender. They are not trained, they don't have enough data, and no one is sitting around going, well, you know, who are the segments of our population? How well does it work in each one? Okay? And they should be, but they're not. They're just saying, well, most of our people look, oh, this works pretty well, we'll just do that. So there is evidence to back that up. And it's, I want to make it clear, it is sort of an implicit bias. And to my knowledge, none of these companies are saying, well, we don't like those types of people, so we'll make it this way. It's just a manifestation, right, of the way that they're training and operating the models. Yeah, so that's very real, and it is completely unacceptable.
It's unacceptable. How can it be allowed if it's a known bias?
Right. Ask all the people who've gone to jail. We need to have like better regulations. We need firmer laws, and we're starting to get them. So I'll give you an example. Many municipalities are now banning the use of facial recognition in like police work and identifying people. Okay? Now, that's a draconian measure, but maybe we need that until we show that they're not biased. Fair enough, right? Yeah.
I have not taken a flight out of Detroit Metro Airport where I had to show an ID in well over a year, and I'm also coming back into the country. It's all facial recognition now, so there's some confidence in that.
Yep.
Quite a lot.
For some groups of people, it works great. Yeah.
First of all, thank you for this really amazing talk, very engaging and such an interesting topic. I think for me, I have so many questions, but I'm going to try to kind of put it into one. What was most humbling and deeply unsettling for me was that JAMA article.
Yes.
I'm a physician myself,
Yes.
and to think that with my over decade graduate and postgraduate level training and years of experience that a machine can beat me and may replace me in my lifetime is scary in terms of job security. So have you already seen data on whether it's like people losing their jobs or lost job opportunities as we are now, which I think surely will happen. So my second part of the question is, I have young kids with me. They're about 15 to 20 years from entering the workforce. What does it mean for them?
Oh, wow. Okay. Those are great questions. So as far as the first question goes, obviously, where this is happening in companies, it is not something that they go around having a lot of public relations about and communicating how it's happening. So no, there is not great data on this. Certain companies like Deloitte and McKinsey publish these jobs most at risk. And it's funny because each time you look at them, they do these like every half year. It becomes like almost every job has some risk and some a little more than others. It used to be kind of like the more customer experience, like customer service, but now it's starting to be what they call like higher level. Okay, so what I would say about like professors and physicians is that even though some particular aspects of what we do could be sort of outsourced to a machine that could do that aspect better, because of the broader system in which we operate takes much longer to change, we will have quite a long runway to figure out how to adapt to these changes, but we've got to be on it. So example, I know some people in the medical school, and they're already thinking, gee, how can I embrace this and make myself a better diagnostician, clinician, et cetera? For me, I talked about that sort of humorous. I asked my students, I've been thinking about this for years. How can I be a better professor by incorporating this and minimize the risk at the same time? So that's kind of how I would think about that. I think it's good that it's galvanized your thinking, but at the same time, I think it's going to take some time on the runway. The other one would be, I have no idea, okay? All I can say is that it's going to be a much different world than the world we occupy today. And from what I've seen, the parts of us as humans that are uniquely humans, that machines, there's no evidence that machines will ever have that feeling, emotion, if you want to call it intuition, almost like some of the holistic aspects of all of those. That's going to become more and more rare and important as machines do more and more of the other types of things. Now, how does that translate to what should young people learn? I have no idea. That is a huge question. It's actually one of those that I had up there, like sort of the techno education, like the future of teaching and learning, and how should we be teaching our students, and what should we be teaching them? Because we have these discussions at Ross as well. So it's a great question. I mean, maybe the best thing is just to kind of stay on top of what it's doing, and all of us, both you and your children, so that like we just have a sense for where we are, because it's not going to be a linear path. Like you said, it might be exponential, but even the direction might be kind of curvy. So great question. Sorry, I didn't have a very good response to the second one.
And when you say, like at this point, it's the human aspects like emotion and those things.
Yes.
But do you think those things can be taught too?
So I don't know that they can be taught, but I think we all need to have a better understanding of how we operate with those characteristics, feelings, emotions, so that we can better do what we do. It's my hypothesis, right? Because there's no straight line between current cognitive functions and that, and I don't ever see that happening. So, yeah. Thank you. Great question.
Another online question.
Okay, yeah.
Can AI help us know what we don't know, or are large language models limited to what they learn on? In other words, can it address the unknown unknowns?
Okay, so finally, a question I can just answer with one word: yes. And the best example of that is the Nobel Prize 2024 Chemistry Protein Folding. So we know that protein folding is how leads to identification mechanisms, diseases, etc. But we don't know what are all the possibilities, what's more likely to be efficacious. And now AI has just gone through and identified all of these new possible structures, and they're being open sourced. So AI didn't just look at what existed, it's actually generating new potential molecular structures, protein folding structures, and so yes.
Thank you for your time today. So I read about a year and a half ago an article about a guy working with, I think this was around GPT 3.5, that kind of generation, working with this model, and he thought, this thing is conscious. And this was kind of a clickbaity title, but it was a good article. This is at the time at the early stages of 3.5, and as you said, we're still at the early stages. So if an expert like that can be bamboozled, if you want to say that, into thinking that this is a conscious entity, I don't think that's the case, and most of us, I don't think, agree. But if at this early stage we're there, that makes me wonder less about the models themselves, but what are we and what have you learned about humans as you study these neural networks and how they process things and how they respond to us? What has that taught you about us, you, all of us?
Right. That is such a great question. Because when I work with groups, one of the first things often I say is, I've learned more about humanity than I thought I would by learning about these machines, okay? So one of them is, what happens, so we have now an experiment of, if we take humans, or human-like, right, and remove emotion and feeling, what are we left with? That's a scary thing, because that's what these machines are, in a way, right? So it's given me a few things, a much better appreciation for the role of feelings and emotions, processing them, how we use them when we interact with people. There's a lot of subtlety there, right? So that would be the first one. The second one would be our incredible limitations and how we need to learn to embrace them. So one of them I showed here. We're not good with super big, we're not good with super small, and as we have these new team members that we're working with, we better get a better mindset and sort of, that's something I think we can do better with, so that we can now have better ways of saying, you machine, you ought to be able to do this because it's 850 million, and I know it will take you about 10 minutes to do that. And the reason I say that is because there are so many problems that I talk with business people about, and they come at it from a point of view of implicitly human ability and limitation. Like that's their starting point. And they don't even realize that we all do that. We are not wired up our whole lives. We've been wired up for what is possible for a person, 2 people, etc. It's just normal. We don't even think about it. Now imagine if a person could read and understand a whole book perfectly in like 2 minutes. What would you do? Like, how do we interact with that? So those are just some examples, but it's a great question because after a few years of working in this area, I started realizing, wow, I'm learning. It's kind of like I spent a few years living in Japan, and I thought when I went to Japan, I'll learn all about Japanese culture, which I did, and it was great. I learned much more about American culture when I lived in Japan, which is exactly your question. So it's a great question, yeah. Thank you.
Another online question.
Sure.
Which is that, so there are examples like purchasing, so on some company that everybody buys from online and then makes purchasing suggestions, or some online streaming service where people watch TV shows without naming either of them. And they also make suggestions. And so this used to be called algorithms.
Mm-hmm.
And the question is, are they still algorithms? And maybe the first question before that is, what is the difference between algorithm and...
Yeah, so there really isn't a difference because when you think about it, no matter what AI is doing or the model for the AI, it is an algorithm. I mean, the algorithm is like sort of how it gets from one end to the other. A trained model, already trained model, is an algorithm that says, first do this, put that there, run it through this gigantic, billion parameter model, and then give me a percentile for what the next word should be, starting with 99, 97. Choose the first one, or if someone dials, heat it up a little, choose maybe the third one. So trained models are a subset, a type of algorithm, in my opinion. So I think the companies, whenever you hear a company describe what they're doing, they're describing it in a way that advances their own profitability objectives. So if they say we're using an algorithm or AI, lots of companies are saying AI now because it's kind of a thing and sounds really good, even though they've been using that for a while and they never called it AI before. So without naming any names. So it's a good question. Yeah. Mm-hmm.
Thanks.
Yes.
Thanks. First of all, I worked with Jonathan Chen and his group that put that JAMA paper.
Yes.
It's fair enough that the first
Can you get a little closer to the mic?
Yeah.
Sorry, the first order, they got it right. The AI got it right. But there's this big diagnostic, we teach diagnosticians, when you hear hoofbeats, think horses, don't think zebras. So the data set that they used had horses in it, not zebras. And secondly, a physician takes care of the second, third order problems. What happens after the diagnosis? You start a therapy, and what are the complications? So my concern is AI is working now on un-AI data sets. Many people, or some people have thought in the future, AI is going to work on AI manipulated data sets, which will create a spiral.
Yes.
Do you have any thoughts on that?
Yeah, no, first of all, thank you for that clarification. And it sort of dovetails a little with the question over here. One study doesn't prove anything. And certainly, it does not mean that, okay, we don't need doctors. It just means maybe as we learn more, we can find ways over time, to better serve, customers, patients, whatever they may be. As far as the types of data we're feeding in, your sort of the end of your question, yeah, I'm just not sure about that. That's a tough one. I would say, though, related to that there is the amount of evaluation in the wild, I would call it, like out there that people are really doing, It's just meager relative to what we need. So as an example, we've rolled out these GPT products here at UM GPT and others, which is great. But the amount of research we're doing to learn from our students what might work or what not, or other members of our community is just, it doesn't match the need. So yeah, I hope I didn't misrepresent the study, but I did think it was an interesting data point. It's a data point, right?
Both at U of M and at Stanford, they're using AI to do the interpretations of the physician-patient interaction.
Yes.
Which it hopefully will get rid of this. It takes 2 hours of documentation for 1 hour of physician interaction.
Yes.
It can make us be better physicians at dealing with the emotional and feeling actions of a miserable life.
Absolutely, and that's what we all need. Thank you. Thank you very much.
It's okay if we keep going a little? There's some
Sure.
great
Yeah,
questions.
that's fine. Sure.
Okay, so just following up, so the AI originally learned how to do medical diagnosis from doctors, and eventually it's going to learn from AI, and as more and more AI is going to be learning from AI, and I see this sort of exponential cascade. What do you envision there?
Yeah, so that's happening in so many ways that we didn't expect. The first thing I would say is we cannot categorically say that if an AI is training on other AI-produced data, that is going to lead to terrible outputs. We cannot say that because we don't have enough research. We do know that the variation and variety of data produced by humans is much higher than that produced by machines. So there's some hypotheses that we could form about that. But we need more research. We need research and evaluation to determine that type of question. Yeah. Yes?
Please get close to the mic. Yeah.
I have a question. Do you think that jailbreaking will ever be never happen, or there's going to be a point where it's not a concern anymore?
How does that? So I think I get the context of the question, but the AI connection to jailbreaking,
I mean, make it go outside of its rules.
Okay, I get it. Okay, so if we have Apple Intelligence here, and it's shaped to answer in certain ways, and then some people want a so-called jailbreak, which just means get it to operate outside of its boundaries. So the question is, do I think that's going to happen, or is that going to become a thing, or?
Make it so that AI, you won't be able to get it to go outside of the boundaries that have been set.
That have been set. Yeah, I think it's a tough problem. It's mostly a technical problem. I think that a lot of the people who are interested for various reasons for jailbreaking, some of which are legit, like doing research, are just using open weight and open source models like Llama, right? I mean, if I wanted to do something like that, I would probably just go and use one of those open source trained models, and I could do my own reinforcement, human learning feedback. I could do my own fine tuning. So yeah, I think that's a risk, that would be on my slide. And I haven't seen too much yet. There might be cybersecurity, people who are, interested in doing stuff like that. Yeah. Were you interested in a particular domain or reason for jailbreaking?
On ChatGPT, I've played around with ChatGPT 4.0 and I've found some jailbreaks.
Yes.
I mean, it seems like, I don't know, it seems like it's pretty easy to work around and get it to do stuff that you don't want it to do.
Yeah, and that's absolutely a risk. And I think I know what you're talking about. There was one, design a new bioweapon that blah, 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 or something like that, right? That kind of stuff, if you prompt it the right way. Yeah, I think that's a technical problem, and there might be other disciplines that might be involved with solving that. Yeah.
I also have another question. I mean, with...
Can I, maybe you can save that, because we have 2 more questions over here. I'd like to finish up with the last 2 questions, and then
Thanks
you can come up afterwards.
Yeah. Mm-hmm.
Thank you, Dr. Nigel.
Yes.
My question is regarding, you said that AI, at UFM, you have AI tutors for the students.
Yes.
And that really intrigued me.
Yes.
Because I teach in a community college.
Mm-hmm.
So how do you have ethics or a check? Because a student can be more open with the AI to get the solution. The tutor, a person, would try to show them.
Right.
And the AI, and that's why students are buying in ChatGPT 4.0 to do the work for them.
Yes,
So
yes.
the AI would give it. So what is, and how are you guys, or do you have a solution that we could incorporate? Or
That's a fantastic question.
Thank you.
So let me speak more broadly. I think that might be better. There are some universities in the Big Ten that have created an AI tutor that is fine-tuned like Khan Academy to do exactly what you said. So a student says, what is this framework? Explain it to me. And it would respond more as a tutor, not as someone that's just giving answers. Like it might respond with a question, like why do you ask or something, okay? Some universities. Other universities are rolling out a system that basically is intended to just provide responses that are accurate. Now, in my opinion, we should wonder about why one is designed one way and one is designed another. What are the goals? What are we seeing empirically? So those are all great questions. And the only advice I would have for you is to think about the very small technical lift that it requires to sort of create one of these, it's called prompt orchestration. So when the student puts it in, it goes into another little you could call it pre-model system that says prompt
engineering?
Architecting. Well, it's not engineering. They usually use that just for the end user. So if the student puts in, write my essay for me, that goes into another system that says, okay, GPT, you will take the prompt, you will pretend you're an AI tutor, you will never give simple answers, you'll be Socratic, you'll be nice, you'll be humorous sometime, and oh, by the way, all of your questioners are like between the ages of 18 and 30, for example. That's not difficult to do. That's very easy for IT departments to do that. So that's what I would say about that.
There's no solution as such.
Not off the shelf. Yeah, it requires just a little bit of technical effort. Yeah.
Thank you so much.
Thanks for the question.
And our last question.
Okay, where am I going here?
Right here.
Okay, yes.
Thank you, Professor Melville.
Sure.
At the beginning of your talk, you mentioned a professor who taught you how to think. I think
Yes,
you called,
right.
maybe Dr. Cromer?
Dr. Cromer, yeah.
I was wondering if you could maybe bullet point that.
Okay, yeah. So, we studied with Dr. Cromer solid-state physics. Solid-state physics involves really crazy behavior of particles that sometimes act as waves and sometimes as particles. Heisenberg, all that stuff. And so how do you get your head wrapped around that stuff? Like, how do you even start to envision that? So the way, he would often give us these very, I guess you call oblique examples of why this might be happening to help us understand that. Some from everyday life, some not. Number one. Number two, he would include historical accounts. So it wouldn't just be, today we're going to study the Heisenberg uncertainty, or we're going to study quantization, or we're going to study quantum dots, or something like that. He would say, years ago we were in the lab, and we did this. And there was a molecular beam epitaxial thing that shoots the atoms and puts them in. And he said, and then we noticed this. So then we went, so by giving you a narrative of how that actually happened, the equation in the book, it's much easier for humans to pick it up that way, right? And then the last one would be approaching problems from different angles instead of just the usual. So, in these physics classes, it's like, solve this problem for that, and then you have to figure out the equations and solve the equation. And yeah, he would always, okay, so I'll never forget. His exam, his midterm was a Weider midterm, meaning most people would leave after the midterm because they didn't score high enough. So this is one of my favorite Herb Cromer stories. So we all took the exam. There are about 35 grad students in a small lecture hall. And we took the exam. Then he comes back and says, okay, I have the results. And he's so happy. And he's passing them out, but we don't know what the cutoff level is. So I get my exam and it's like 36. I'm like, okay, that's the worst score I've ever got in my life. Clearly I knew one problem out of 4, okay? And then he goes up to this board in a big flourish and writes a number on the board. And I don't remember the exact number, but it was something like 25. And he turns around and he says, anybody who got lower than 25, I'm going to have to ask you to leave. And like most of the class leaves. And there's like 6 of us left. And that was the biggest like OMG moment for me. Like, I do not understand what is going on right now. And from that moment forward, the whole class changed. He really like got to focus on us and how our minds work and sort of the thought process. So I have so much gratitude for him, and I have tried in my own way to incorporate that ethos into what I do. So great question. Yeah.
The human element is so encouraging.
The human element, right.
All right, well, thanks everybody for sticking around. Thanks so much, Nigel, Dr. Melville.